In this video, I'm going to explain how to draw Lewis dot diagrams and how you can use the periodic table to easily find out what the Lewis dot diagram should look like. Now, first, when we're looking at the periodic table, we should know we've got some groups. We've got group 1, 2. We're going to skip groups 3 through 12 because they don't really follow all the rules. But then we're going to come back to group 13, 14, 15, 16, 17, and 18. Now, what are Lewis dot diagrams? Lewis dot diagrams are an easy way to show the number of valence electrons an element has. When you draw Bohr models, you tend to draw all of the electrons. But when I come down here to bromine, I don't really want to have to draw a Bohr model with 35 electrons. So instead, I'm going to draw a Lewis dot diagram. Key thing for Lewis dot diagrams, you always in the middle put the name of the element in its symbol form. So if we start with that bromine like I was talking about, I'm going to put bromine on my screen here. Always capitalize the first letter, lowercase the second if there is a second letter. Now, to know the number of valence electrons, the trick is to look up. If it's in group 17, it's going to have 7 valence electrons. What this means is I'm going to come up here and start drawing some circles. I like to start at the top and work my way around clockwise. So 1, 2, 3, 4. If there's more than 4, I go clockwise again. 5, 6, 7. So bromine in group 17, this is what a Lewis dot diagram would look like for it. This is really useful when you go to make chemical bonds later on. To show this again, let's look this time at boron. Boron, same situation. We put the letter at the top. We're going to see that it's in group 13. Thus, it will have 3 valence electrons. So I'm going to go 1, 2, 3. And I can show it like that. If instead, let's say I have krypton over here, uppercase K, lowercase r. Now, I've been using dots. You can also use X's. That works too. But remember, I want to go around my circle first, or around my letters first. So 1, 2, 3, 4, 5, 6, 7, 8. If they're in group 18, they are going to have 8. This would be the most you would have on a valence electron or Lewis dot diagram situation. Let's do 1 or 2 more. Magnesium. Go ahead and see that it's in group 2 and write it out. So Mg, make sure we are putting them around. Don't put them next to each other because there's only 2. I don't double up until I've reached 5. Okay, I'm going to do a few more. Feel free to pause the video as I introduce the element so that you can practice drawing it before checking your answers. So let's go ahead and do phosphorus next. So go ahead, pause the video, try to draw it, and then now check your answers. So phosphorus is in group 15. 1, 2, 3, 4, 5. Your Lewis dot diagram should look like that. Go ahead and this time let's do germanium. Go ahead and pause the video if you need to. Germanium is in group 14, so it has 4 valence electrons. 1, 2, 3, 4. Okay, and let's do 2 more. Let's go with hydrogen this time. Hydrogen, uppercase H, 1 valence electron. Okay, and for our last one, let's do sulfur. Okay, 1, 2, 3, 4, 5, 6. Okay, and it looks like that. Hopefully that helped. You can practice. As I said, the middle of the periodic table doesn't really follow all the valence electron rules, so most of your teachers will not require you to do a Lewis dot for them. But as always, just look, is it in group 1, 1 valence electron, group 2, 2 valence electrons, group 3, by group 3 I mean group 13, but it has 3 valence electrons, and so forth. Now, I do want to, that's not 18. I do want to point out one exception. The only exception is helium here. Although it is in group 18, because it is in the top row and it only has 2 electrons, its Lewis dot diagram will look like this. If we remember from drawing Bohr models, we know that helium is happy with 2 electrons because the outermost shell is happy with